That sound, that hollow metallic rattle coming from the top of your Honda engine on a cold morning, you have heard it. Maybe you told yourself it was nothing. Maybe you let it warm up and watched it disappear, and you convinced yourself everything was fine. It was not fine. That sound is your engine sending you a distress signal, and every single time you ignored it, a microscopic amount of irreversible mechanical damage was accumulating inside one of the most precisely engineered components Honda ever produced. By the time this video ends, you will understand exactly what is dying inside your K20 or K24, why Honda knew about it, why your dealership absolutely loves when you do not know about it, and how a handful of informed decisions, costing you almost nothing, can be the difference between an engine that runs for 400,000 kilometers and a catastrophic internal failure that turns your pistons and valves into scrap metal at highway speed. The variable timing control actuator, Honda called it VTC. Engineers inside Honda's Tochigi research facility called it one of the most elegant solutions to variable camshaft timing ever committed to production metal. The premise is simple, and the engineering behind it is brilliant. Your K-series engine has an intake camshaft that needs to shift its timing relative to the crankshaft, depending on what the engine demands. At idle and during cold starts, you want a conservative, stable timing position. At high revs under load, you want the intake valves opening earlier, allowing the engine to breathe more aggressively and produce significantly more power. The VTC actuator sits at the nose of the intake camshaft and accomplishes this shift using engine oil pressure routed through a spool valve controlled by the ECU. It is a hydraulic rotary actuator, and its internal mechanism uses a set of precisely machined vanes inside a rotor housing, with oil pressure pushing those vanes to rotate the camshaft position within a defined range of roughly 50 crankshaft degrees. When everything is working perfectly, this system is invisible. You never think about it. The engine just responds. Now here is where the molecular reality of what happens inside that actuator becomes something every K-series owner needs to understand: the locking pin. Inside the VTC actuator, there is a spring-loaded pin, machined to extremely tight tolerances, whose sole purpose is to lock the rotor in its fully retarded position when oil pressure is insufficient to hold it in place. During a cold start, your oil is thick, your oil pump has not yet built full system pressure, and the VTC relies on this mechanical pin to hold the camshaft timing stationary until hydraulic pressure takes over. That pin engages a precision ground detent bore in the rotor housing. The engagement depth is measured in fractions of a millimeter. The spring force holding that pin in engagement is calibrated against the hydraulic pressure threshold, at which the system transitions from mechanical lock to full hydraulic authority. This is an extraordinarily precise mechanical handoff, and it depends entirely on one thing: clean, viscosity stable, pressure-retaining engine oil delivered to that actuator within the first fractions of a second after startup. When that oil is degraded, when it has lost its viscosity index, improvers through thermal cycling, when it has accumulated combustion byproducts that alter its film strength, when the oil level has dropped below the pickup threshold, or when the oil change interval has been extended just slightly beyond what the engineering tolerances assume, the hydraulic pressure at the actuator during that cold start transition falls below the threshold required to smoothly relieve the locking pin and assume rotational authority over the rotor. The pin begins to disengage under insufficient pressure. The rotor begins to oscillate between the mechanical detent and the first degree of hydraulic engagement. The vanes inside the housing flutter. The rotor chatters against the housing walls. And that is the rattle. That specific, rhythmic, cold start rattle that owners describe as a death rattle is the acoustic signature of a VTC actuator whose internal locking pin is no longer making clean, decisive contact with its detent bore, because the bore itself, after thousands of these degraded cold start events, has begun to wear. The precision ground bore becomes an oval. The pin no longer seats. The spring rate is no longer sufficient to overcome the now sloppy clearance, and the system that was once held in mechanical lock during cold starts now sits in a state of constant low-amplitude oscillation every single morning of your engine's remaining life. Honda knew the sensitivity of this system. Internal service documentation from the mid-2000s identifies oil quality and change interval as primary factors in VTC actuator longevity. The recommended oil specification for the K20 and K24 was not chosen arbitrarily. The 0W20 or 5W30 full synthetic specification exists specifically because the VTC actuator's hydraulic circuit requires rapid oil pressure buildup at sub-zero ambient temperatures. The oil galleries feeding the actuator are narrow. The spool valve controlling oil routing to the vane chambers has clearances measured in microns. Degraded oil with elevated viscosity at cold temperatures creates a pressure drop across these galleries that delays actuator pressurization by fractions of a second. And in engine time, fractions of a second of uncontrolled camshaft oscillation represent thousands of micro impacts between the rotor vanes and the actuator housing. Multiply that by every cold start across a maintenance schedule that used conventional oil changed every 10,000 kilometers, and you have the engineering explanation for why a K-series engine with 80,000 kilometers on it can sound like it has a bag of gravel inside the valve cover. Now, the timing chain tensioner, and this is where the story becomes genuinely dangerous rather than just expensive. The K-series timing chain system uses a hydraulic ratcheting tensioner to maintain correct chain tension across the full operating temperature and RPM range of the engine. The tensioner body contains an oil pressure-fed hydraulic cylinder that pushes a tensioner blade against the timing chain and a ratcheting pawl mechanism that prevents the tensioner from retracting once it has extended to compensate for chain stretch. The ratcheting teeth on the tensioner piston are designed to allow extension in one direction only, holding the chain taut under all conditions. Under ideal conditions with clean oil, correct pressure, and a tensioner that has not seen excessive heat cycles, this mechanism is robust and reliable. Under the conditions created by an engine that has been run on degraded oil through extended change intervals, the story changes at the microscopic level. The ratcheting pawl teeth are hard steel. The tensioner piston body is aluminum. The oil film between those components is the only thing preventing direct metal-to-metal contact under the cyclical loading of chain tension variation. When that oil film is compromised, when the oil has lost its anti-wear additive package, when particles from a worn VTC actuator are circulating through the same galleries that feed the tensioner, the pawl teeth begin to wear the aluminum piston body at each ratchet engagement point. The clicks you sometimes hear from a warm engine under deceleration, that light mechanical ticking under low RPM load reduction, those are the ratchet teeth skipping. The tensioner is momentarily losing its ability to prevent retraction under the shock loading of the timing chain during aggressive fuel cut or engine braking events. Each skip event allows the chain to go momentarily slack. A slack timing chain on a K-series engine, even for a few degrees of crankshaft rotation, alters the phase relationship between the crankshaft and the camshafts. And when you understand that the piston-to-valve clearance in a K20A2 at maximum lift and overlap is measured in the range of 1 to 2 millimeters under ideal timing conditions, you begin to understand exactly how much margin exists between a correctly functioning timing system and catastrophic piston-to-valve contact. There is almost none. The industry built a perfect storm around this failure mode. Dealerships offer timing chain service intervals that involve replacing the tensioner and guides as a package. The service cost at a main dealer ranges from several hundred to over $1,000 depending on market. The VTC actuator itself, a Honda OEM replacement unit, carries a parts cost that is completely disproportionate to its actual manufacturing complexity, and none of this is disclosed to the owner during the purchase of the vehicle. The service manual covers the maintenance intervals for oil changes, but does not communicate in owner-facing language the direct causal relationship between oil degradation and VTC actuator wear. The dealership technician who hears the cold start rattle at your scheduled service appointment and tells you it is normal for these engines to rattle a little when cold is either misinformed or is aware that an informed customer asking the right questions about oil quality and change intervals would cost that service department a significant repair bill several years down the line. The suppression of this information is not a conspiracy. It is a simple, economically rational decision repeated across thousands of individual service interactions. The knowledge that a $5 bottle of concentrated engine oil flush, used before an oil change, combined with switching to a high-quality, full synthetic meeting Honda's HTO6 specification and reducing the oil change interval to 5,000 kilometers, you can extend the service life of a VTC actuator by potentially 100,000 additional kilometers, is knowledge that directly reduces service revenue. A machined billet steel VTC actuator gear from a reputable aftermarket supplier eliminates the wear mode entirely because it replaces the aluminum internal components with components that simply cannot fail in the same way. The upgrade costs a fraction of a dealership repair bill. The information about it exists in engineering forums and community spaces, but never inside a dealer service bulletin. Here is what the commercial fleet data confirms. Operators running K-Series engines in high-cycle applications, courier fleets, driving schools, track day preparation shops, who adopted 5,000-kilometer full synthetic intervals and upgraded to Billet VTC components, report mean time between VTC-related failures that is statistically indistinguishable from infinity across their operating data. These engines do not develop the cold start rattle. They do not exhibit chain tension or skip. The piston-to-valve clearance remains within factory specification across hundreds of thousands of kilometers because the root cause of the degradation chain was interrupted at its origin point. Oil quality and change frequency. What you need to do is specific, and it costs almost nothing relative to what you are protecting. Before your next oil change, with the engine fully warm, add a concentration of quality engine flush product to your existing oil, approximately 300 to 500 milliliters for a K-series sump, and allow the engine to idle for 10 minutes. This mobilizes varnish deposits in the oil galleries, including the narrow galleries feeding the VTC spool valve, and allows the subsequent drain to remove contamination that a simple cold drain cannot reach. Drain completely. Replace with a full synthetic oil meeting or exceeding Honda HTO6 specification, in 0W20 for K20 applications or 5W30 for K24 depending on ambient climate. Replace the oil filter with a genuine Honda unit or a verified OEM quality alternative. Set your change interval to 5,000 kilometers and treat it as non-negotiable. If your engine already exhibits cold start rattle, source a machined billet VTC actuator gear from a reputable supplier. Several exist in the enthusiast market, and have it installed during a valve cover off service. While the cover is off, inspect the timing chain tensioner for visible wear and replace it with an upgraded unit if any ratchet tooth deformation is visible. The entire parts cost for this preventative intervention is a small fraction of the cost of a damaged engine. For K-Series owners who want to go deeper on this, who want access to specific supplier recommendations, collective buying data on billet VTC components, community-documented failure analysis, and the real-world case studies of engines saved and engines lost, the KuroCars community exists specifically for this. The knowledge base there represents thousands of hours of collective engineering investigation that no dealership will ever hand you voluntarily. They will not want this video to stay up. The repair industry's business model depends on you not knowing what you just learned. Share this with every K-Series owner you know, not as a recommendation, as an obligation. Because somewhere right now there is a K20 or K24 owner hearing that cold start rattle, telling themselves it is nothing, and driving toward an engine failure that was completely preventable from the moment they first heard the sound. In the next video, we are going inside the transmission tunnel of a specific European luxury manufacturer's 7-speed dual-clutch unit, where an internal software calibration parameter that the factory can update in 8 minutes, but will only perform as a paid service, is causing premature clutch pack wear in hundreds of thousands of vehicles. The documentation exists, the internal memos exist, and the cost to the consumer has already crossed $1 billion in preventable repairs. You will want to see this. This